Hello all. Today I will discuss a problem from the game theory using the dominance property. So the given problem with the outcomes. So using the dominance property we have to solve this particular game. So before solving the game, the dominance property for rows always should be x less than or equal to y, and for columns x greater than or equal to y. So in the dominance principle, when do we apply? Suppose when one particular outcome is dominating other outcome. So here in this particular game, we are trying to minimize this outcome. Right? We'll see how we can solve this particular game using dominance principle. So now here what I am doing is I am considering this as 1, 2, 3. So we will find which outcome is dominating by comparing 1 and 2, by comparing 1 and 2, 1 and 3, 2 and 3. So 1 and 2, 1 and 3, 2 and 3. So by taking the row 1 and 2. So we'll compare. There are other methods also, but this becomes easy. So 1 and 2. 1, 7, 2. 1, 7, 2, 6, 2, 7. So here 1 is less than 6, 7 is greater than 2, and 2 is less than 7. So here by comparing 1 and 2. Now row 1 and 3. 1 is 1, 7, 2. 3 is 6, 1, 6. So 1 is less than 6, 7 is greater than 1, and 2 is less than 6. And 3. Now for row 2 and 3, 2 is 6, 2, 7, 3 is 6, 1, 6. Here 6 is equals to 6, 2 is greater than 1, and 7 is also greater than 6. So for rows it should be x less than or equal to y. So here 2 less than, and here also we have 2 less than, but here in this particular row we have 2 greater than symbols. See, here 2 is greater than 1 and 7 is greater than 6. So hence we will be deleting this particular row. So third row will be deleted. So now we will be having 1, 7, 2, 6, 2, 7. So taking the 2 rows. So what are the 2 rows now? Player A is having 1, 7, 2, 6, 2, 7. So here this I am considering as column 1, column 2 and 3. So column 1 and 2, by taking the column 1 and 2. So 1 is less than 7, 1 is less than 7, and 6 is greater than 2. Now column 1 and 3. 1 which is less than 2 and 6 which is less than 7. Column 2 and 3. So column 7 which is greater than 2 and 2 is less than 7. So dominance principle for columns, here the principle for columns is x should be greater than y. Should be greater than y. So here 1 less than, 1 greater than, here 1 less than and less than. So 1 less than and greater than, so there is no dominance. So this exactly opposite, that means 2, 7 which lies in the 2, 7 which lies, see this one, in these 2 and 7 lies in the third column. So 2 and 7 lies in the third column. So here we are deleting the third column. So now here what we are doing, we are deleting this particular column. So remaining outcomes will be 1, 7, 6, 2. So what we will do, we will find out the row minimum. So here in the first row it is 1 and here it is 2. So column maximum, here it is 6 and 7. So this will be max min. So this one will be minimax. So maximin is not equal to minimax. Hence there is no saddle point. So we can solve this problem. That means this game is not involved with the pure strategy. So we have to solve using the mixed strategy, and the matrix is a 2 by 2. So here we have to find out the oddments. So oddments we have to find out for this particular matrix 1, 7, 6, 2. So oddments we have to find out. 7 minus 1 we will be writing here 6. 7 minus 1. So 6 minus 2 is 4. And 6 minus 1 is 5. 7 minus 2 is 5. So oddments for row and column. So this one, which will be considered as P1 and P2, and this one will be considered as Q1, Q2. This one, this column, this row, P1 and P2. So P1, which is equal to 4, this is the 4 probability. I am finding out the probability for the row 1. So 4 divided by 4 plus 6, that is 4 by 10. 4 by 10, which is equal to 2 by 5. So 2 by 5 means the probability for second row will be definitely 3 by 5. So here it is 6 by 4 plus 6, that is 6 by 10. So 6 by 10 is equals to 3 by 5. So oddments for columns Q1 will be 5 divided by 5 plus 5, that is 10. So 5 ones, so it will be 1 by 2. Here also it is 5 by 10, that will be 1 by 2. So we can say that we can, now we have P1, P2, Q1, Q2. So value of the game can be calculated as 1 into 4 plus 6 into 6. 7 into 4 plus 2 into 6 divided by the probability is 4 plus 6. So let us calculate the value of the game. It should be equal. So value of the game V. So first, what do we have here? We have 1 into 4, 6 into 6 divided by 4 by 6. So taking the value 1 into 4 plus 6 into 6 divided by 4 plus 6. So 1 into 4 is 4 plus 6 into 6 is 36. 6 plus 4 is 10. So 40 by 10. So 10 into 4 is equals to 4. Second row, second column, if we take 7 into 4 plus 2 into 6 by 4 plus 6. 7 into 4 is 28 plus 6 into 2 is 12 by 10, 28, 40 by 10, that is equals to 4. Next, 1 into 5 plus 1 into 5 plus 7 into 5 divided by 5 plus 5. 5 plus 35 by 10, that is equals to 40 by 10 is equals to 4. Next, 6 into 5 plus 2 into 5 divided by 5 plus 5, 35 plus 10 divided by 10. So 40 by 10 is equals to 4. So in all the cases we should get 4. If we get any other value, then you made wrong. Somewhere else you made mistake. So hence value of the game V is equals to 4. This is the best example solving the game without saddle point. So previously we have seen solving the game with the saddle point, solving the game without saddle point. Here we have seen, and also we have observed the application of the dominance principle in the game theory. Thank you.